Welcome to SingleCrystal 5. In this tutorial, we'll show how you can calculate the Fourier transform of an image, including interactive measurement and manipulation. Let's start with a simple image, such as this row of dots. For best results, we want a square image, so we'll resize to neatly fit around the image. We need to tell SingleCrystal which parts of the image we're interested in, the black or the white. Here we want the black area to be treated as background. To do this, we'll open up the parameters inspector and go down to the pattern coloring group. We're going to choose the color option, and we want to ensure that the reverse option is set. This way, only the dots will be used for the Fourier transform calculation. This is without, and this is with the reverse option. We now have two choices. We can generate an immediate Fourier transform using the pattern Generate Fourier Transform command. Opening up the sidebar shows our original mask and then the Fourier transform created as a new pattern. And here we have a set of vertical fringes multiplied by a circular intensity function. We have another option, which is to generate an interactive Fourier transform. To do this, we'll go to the View menu and we'll go down to the Fourier Transform submenu and choose Show Fourier Transform. The window has been split in two, with our original or mask image on the left and its corresponding Fourier Transform on the right. Now let's just make our mask a little bit smaller so that all of it fits in, and let's now click on the Fourier transform, and notice that when we click on the Fourier transform pane on the right, we get a dedicated Fourier transform inspector. Clicking on the image on the left, the mask, we get a picture inspector. Clicking on the Fourier transform, we get the Fourier transform inspector. This lets us set the scale and coloring. For example, we could show the range of intensity levels in the Fourier transform using a color gradient. Let's choose a rainbow scale here. We can also adjust the relative scale of the Fourier transform, allowing us to see the finer details. Now, this is equivalent to moving a diffraction screen further away from the image mask. So if we go to the scale group and the Fourier transform inspector, we can drag this slider out and make our Fourier transform larger. We can also use these scale presets that resets to 1 or 2. Now we can measure the interactive Fourier transform relative to the mask by showing a ruler. Go to the tool strip and click on the ruler. Now let's position the ruler over our mask and do some measurements. Let's measure our circle or dot separation, and we have here the right number of divisions, and we can click on the display to show the interval in pixels. Let's go over to the ruler inspector and change that to centimeters. So we're dealing with real units, and we have about 8.5 centimeters between dots in our mask. Now let's do the same for the Fourier transform. Now here we're going to need a slightly larger image. So let's use a scale factor of 8, and let's now move the ruler so it spans a number of fringes. And we're going to need to increase the number of intervals in the ruler. And let's measure the fringe separation. And we have a fringe separation here of 0.12 reciprocal centimeters. So 1 divided by 8.5 is approximately 0.12 reciprocal centimeters. So we do have a reciprocal correlation between the mask on the left and the Fourier transform on the right. We said this was an interactive Fourier transform. That means we can adjust the mask and see the Fourier transform update. So let's try rotating the mask. We'll start by hiding the ruler. And now I'm going to hold the Shift key down and click and drag with the mouse to rotate the mask. We can also change the size of the mask by zooming it. I can use multi-touch to do this. So as the mask gets bigger, the fringes get closer together, and as it gets smaller, the fringes become more widely spaced. Finally, let's try editing the mask. We'll start by duplicating our observed pattern in the sidebar. And we'll make this visible by shift-clicking on its thumbnail in the sidebar. We'll lock the original in place so we can easily move or rotate the copy and see how this affects the Fourier transform. Let's use the Move tool from the tool strip to drag the copy away from the original. I'm just going to hide the sidebar for the moment. We'll now try rotating one row relative to the other using the rotator. And let's try 45 degrees. And we can see the effect on the Fourier transform. I'm going to just move this so that two of the dots overlap. And now we have an interesting zigzag Fourier transform that relates to the angled display in the mask on the left. Now we can do all kinds of fun things with Fourier transforms. This is only the start, and you have the opportunity to explore many more by looking at the library of image masks and Fourier transforms in our gallery window that you'll see at Program Startup. These are designed to teach the concept of convolution in diffraction theory. We hope you find them helpful.